Yeah, from this Mohr circle diagram, we should be able to calculate the radius of a Mohr circle. So please remember, radius of a Mohr circle gives the maximum shear stress. That means, so this CD, CX, CY, CA, CB, so all are giving you the radius of a Mohr circle. Now, how we can find the radius of a Mohr circle? But we already know that radius of a Mohr circle is equal to tau max. But how do we prove it geometrically using this equation? So let us see. So we know CA is equal to CX is equal to R. CA is equal to CX. All are radius. So that is equal to R. So now from the triangle CFX, which is the triangle CFX. So CFX is a right angle triangle. So this is 90 degrees and this is 2 theta. So from the triangle CFX and from the Pythagoras theorem, we write CX square is equal to CF square plus Fx square. So Cx square is equal to Cf square plus Fx square. So what is Cf? Cf is this distance. So how do you find this distance? How do you relate this distance in terms of the known stresses, that is sigma x, sigma y and tau xy. So let me see here. So the distance from here to here is sigma x. This distance is sigma x. And the distance from here to here, the distance from here to here will give you the center of the Mohr circle. The distance from here to here gives you sigma y. That means if you know this distance, half of this distance will be CF, because the distance of the tau xy will be same from the horizontal axis. So what we are doing, we are taking sigma x minus sigma y, so that you will get this distance, half of that is OF, which is sigma x minus OG, which is sigma y, by 2, because we want half of this distance, so by 2. So by 2 plus Fx square, as it is right. So OF is sigma x, OG is sigma y by 2. This is square. This is square. So plus Fx is Fx is tau x square. So this distance is tau xy, tau xy, not xy square. The distance is tau xy. So tau xy square. So if you see this equation, it was exactly similar to R, that is radius of a Mohr circle. So Ca is equal to R square. R, if you want, R is the root of this. The root of sigma x minus sigma y by 2 whole square plus tau xy square. So now we use this relation to find out the maximum and minimum principal stresses. So now from the Mohr circle diagram, how do you find out the maximum principal stress? See, I have already told maximum principal stress is the distance from O to A. The minimum principal stress is the distance from O to B. So from this geometry, we should be able to calculate the maximum and minimum principal stresses. So after you construct this in a graph sheet, you can just directly measure it. Just measure it, measure the distance O to A. That's all. To find the minimum principal stress, just measure the distance O to B. But one thing that you must ensure while constructing Mohr circle diagram is that the scale of x and y must be same. That means if you are taking 10 MPa is equal to 1 centimeter, the same 10 MPa is equal to 1 centimeter you have to take in y direction also. So if you take different scales for x and y direction, you will not get the Mohr circle diagram. So because you have drawn this to the scale, you can straight away measure the distance OA and OB and obviously CD and all that. However, it is possible to derive the analytical equations from this Mohr circle diagram. So here we will see how we can get the equations for maximum principal stress, minimum principal stress and shear stress. So see the equation sigma 1. So sigma 1 is equal to OA. Refer the diagram there. Sigma 1 is equal to OA. So this OA is equal to OC plus CA. What is OC? OC is this OC plus CA. So OC is what? Recall what is OC? OC is the center of the Mohr circle. So while doing the derivation, I told center of the Mohr circle is equal to the average shear stress. Average normal stress, that is sigma x plus sigma y by 2. So OC is equal to sigma x plus sigma y by 2. So substituting OC is equal to sigma x plus sigma y by 2. And what is CA? CA is the radius of the Mohr circle. So straight away CA is written, which was derived in this equation. So straight away it is written, and this, you recall this equation which was derived analytically, so using the for a two-dimensional stress system, so that we directly got from the simple circle. So similarly for the minimum principal stress also we will do. So minimum principal stress, that is sigma 2 is equal to OB, this distance. So how do you find this distance from the geometry? You see here. So if you know OC, is the center of Mohr circle. So if you know OC, from the OC, if you subtract the radius, you will get this distance. That is what is required for sigma 2. See, from the OC, if you subtract CB, you will get this distance, right? So geometry, from the geometry it is OC minus CB. So OC is what? OC is the center of a Mohr circle. Then what is CB? CB is the radius of a Mohr circle. So center of the Mohr circle, sigma x plus sigma y by 2 minus radius of a Mohr circle. So this equation. So you recall this equation which was derived analytically, which gives the minimum principal stress. So this I did not explain again because it was explained earlier. So the radius of a Mohr circle directly gives you the maximum shear stress. Now coming to the determination of the angle of the plane where the stresses are maximum and minimum. So we use the triangle CFX, which is the triangle, this triangle CFX, which is again a right angle triangle. So from this right angle triangle we are writing tan 2 theta. So tan 2 theta is equal to, from the diagram it is vertical by base. So vertical is Fx, y by x, yes. So this is the vertical Fx and this is the base. So this distance by this distance. So it is Fx by Cf. So Fx is this distance. This is Fx and this is Cf. So what is Fx? This is Fx. So Fx is equal to the shear stress tau xy. Then what is Cf? Cf you can find if you know OF minus OG, you will get Fg by 2. If you do, you will get Cf. That means O to x or O to f, this distance minus this distance. If you do this distance, you will get half of that distance will be this, right? So it is OF. So straight away it is written here. However, that is how it has to be calculated. So OF means O sigma x minus sigma y by 2. That's what is equal to OF minus OG by 2. That is what is this equation. So after simplification, you will get tan 2 theta equation. So this in this equation we can find out the plane in which the stresses are maximum.